Welcome to this video where we'll explore one of the most fascinating topics in computer architecture, enabling 64-bit paging and long mode on x86 assembly language. If you're a programmer, engineer, or simply someone curious about how computers work, then this topic is sure to captivate you. In modern computing, efficient memory management is crucial for performance and security. The 86 architecture has undergone significant transformations over the years, with one of the key milestones being the evolution of 64-bit paging and long mode. These features allow operating systems to access vast amounts of memory, ensuring that applications can run smoothly, even when dealing with enormous datasets. In this video, we'll delve into what 64-bit paging and long mode are all about, how they work together, and why they're essential for modern computing. By the end of this discussion, you'll have a deep understanding of these concepts and their importance in contemporary computer architecture. To begin with, let's set some context. Traditional x86 processors used 32-bit addressing, which limited the address space to 4 GB, not nearly enough for today's memory-intensive applications. The shift towards 64-bit architectures was inevitable, enabling access to much larger memory spaces and significantly improving system performance. At the heart of this transition lies the concept of paging. Paging is a memory management technique that allows operating systems to divide physical memory into smaller chunks called pages. This approach enables efficient use of memory by loading only the necessary pages into RAM, thereby reducing memory wastage and improving overall system responsiveness. In 64-bit x86 architectures, each page can be up to 4 KB in size, but with a twist, the address space is now 64 bits wide, allowing for an almost unimaginable amount of unique addresses. However, managing these large address spaces efficiently poses significant challenges, which brings us to long mode. Long mode is a specific operating mode that modern x86 processors can enter, enabling them to utilize the full potential of their 64-bit architecture. When in long mode, the processor operates on 64-bit wide addresses and instructions, facilitating access to vast memory spaces and unlocking the true power of 64-bit computing. The combination of 64-bit paging and long mode represents a fundamental shift in how computers manage memory and execute instructions. This synergy enables modern operating systems to efficiently utilize large amounts of RAM, ensuring that applications can run smoothly, even with massive datasets. To illustrate this concept better, imagine you're working on a project that requires manipulating enormous files or handling an immense number of concurrent connections. In such scenarios, the ability to access vast memory spaces becomes crucial for performance and reliability. Here's where 64-bit paging and long mode come into play. By efficiently managing large address spaces, they allow applications to operate smoothly, even under intense load. To recap, we've covered several key points in our discussion. The importance of efficient memory management in modern computing, how traditional x86 architectures were limited by 32-bit addressing, and the necessity for a transition towards 64-bit processing. The role of paging as a memory management technique that allows operating systems to efficiently use physical memory. The long mode, which enables processors to utilize their full 64-bit potential, accessing vast memory spaces. These concepts are fundamental to understanding how modern computers manage memory and execute instructions. By grasping these principles, you'll gain a deeper insight into the inner workings of computer architecture and appreciate the engineering marvels that power today's digital world. In enabling 64-bit paging and long mode on x86 assembly language represents a pivotal milestone in the evolution of computer architecture. These features have been instrumental in empowering modern operating systems to manage memory efficiently, unlocking unparalleled levels of performance and security. We hope this video has provided you with an engaging and informative explanation of these critical concepts. If you have any questions or topics you'd like us to explore further, please don't hesitate to ask them in the comments below. Your feedback is invaluable, helping us create content that resonates with your interests and knowledge thirst. If you found this video informative and engaging, consider liking it as a token of your appreciation. Also, subscribing to our channel will ensure you stay updated on our latest videos, each designed to enrich your understanding of the fascinating world of computer science and technology. Thanks for watching, and we look forward to your continued engagement.